Well, it's starting to get awfully dark on my drive to the office in the morning, so summer must be almost over. You know, we had a recent incident here where a lightning strike hit the local high school football field and knocked a bunch of Pee Wee football players right back on their pads. I think it'd be a good idea if we wrote a program to calculate how far away that lightning is based upon how long it takes for the clap to hit our ears. Yeah, I think that's a good idea.
In our first lesson, we started with a very simple sequential program that processed a couple of values. And now we want to add to our repertoire by talking about variables. A variable is a named memory location to which you can assign a value. The nice thing about a variable is during the execution of the program, because you have access to that memory location, your program can modify the contents of that memory location. When we're going to use a variable, the first thing we have to do is declare it. And so we see right here the variable distance being declared. There's a couple of parts to this. The first thing that we see to the left in double is the data type of the variable. Remember that Java is a strictly typed language, and so before you're going to use any variable, the compiler must know what the data type is of that variable. Distance represents the identifier or the name of this variable. There's a few simple rules about identifiers. They can be composed of letters, underscores, dollar signs, and numerals, but they must begin with a letter. Also remember that Java is case sensitive, so lowercase distance and uppercase distance would be two different things. After the identifier, we have an initialization statement, and that's the assignment operator, the equal sign, and then 0. So as the compiler assembles this before the program is executed, I'm making sure that there is a value that I know placed in the memory location assigned to distance, so it equals 0 before it's operated. In this very simple program, I have an expression just below, and the value of this expression right here, 7.2 times 1100, which 1100 represents the speed of sound and feet per second. So 7.2 seconds times 1100 gives me the distance at which a lightning strike has occurred. And so when I execute this, lo and behold, 7.2 times 1100 is assigned to the variable distance, which I then output over here in this system out println statement. So nothing magical. The variable receives an initial value of 0. When the expression is processed, the results of that expression are placed in that memory location, modifying the content, and then I can use that content here in this output statement. Our first version of this program has a little bit of a problem, and I still have that line represented right here. In the 1100, we have a literal value hard-coded into the program, and that poses a couple of possible dangers. Somewhere down the road, another programmer can come along and not know what that 1100 represents and change that value to 1000 or something that doesn't represent an accurate speed of sound. The other problem that we have is really goes in hand with that, and that is we don't know what this 1100 represents without some documentation. And so what we do is we define the 1100 as something called a constant. A constant is a declared value within a program that cannot be modified during the execution of the program. It remains fixed. And we declare that constant, much like the variable. We do it up here in the outside of main, but within the body of the class. And we use the keyword final. Final is the Java word for a constant. Again, we have a data type. This is an integer. We have an identifier, and usually constants are declared in all uppercase letters. An assignment operator and the value that we assign to that. Now what this means is that when this line is compiled and executed, speed of sound will represent 1100 anywhere that we want to use it within the body of the program. So I'm going to substitute speed of sound down here, which will place the 1100 in the expression and still give us the same result that we're expecting. Now, if somewhere down the road some scientists should discover that the speed of sound is actually 1200, the nice thing about a constant is we only have to change it in one place in the program. We can identify, we can modify it right here, and everywhere that speed of sound is found throughout the program, the new value will be placed into that constant. Now, last thing we want to look at in our constant declaration, and if we execute it, we're still going to get the same answer, 7,920. The last thing is the keyword static. Static, when we are declaring constants, static tells the compiler that this value can be accessed outside of an object of the class type. So that means that it is visible throughout all of your classes in this program. Now this iteration of the program modifies it to actually make it useful. In the previous versions, you had hard-coded the number of seconds between the time you saw the lightning strike and the time the sound hit your ears. When you are in the midst of a lightning storm, you're not going to have time to go in, type in a new value, recompile the program, and see what it is. So we're going to add a little user I/O so that the user can run the program immediately, type in how many seconds it is from the lightning strike to the sound, and get a fair warning of how quickly to get out of there. I've added another constant, yard here, equaling 3 feet, so that I can add another expression here to convert the number of feet into yard, just to make the program a little more interesting. I've added the scanner library, so all of the I/O functions of the scanner library are now available to me because I've added this library through the import function. And so I'll put a prompt out there, and notice that I'm using print and not print line. When I use print, it doesn't do the carriage return line feed, and the cursor will be resting right here just past this space, waiting for my input. I think that's a little more intuitive for the user. Then the scanner library is going to go out, call the next double method, and take whatever value is typed at the prompt and put it into my variable in delay. So let's execute this. It's pretty exciting. And my cursor sitting here, I'll put in our familiar value, 7.2. We get the result in yards. That's 2,640. So I/O takes the user input. Usually we assign it into a variable and then use that variable in an expression or simply to output it back out to the screen. In this final iteration of the program, I want to modify it by building in a safety buffer. Human nature says if you know you have 7 seconds, you will use every bit of that 7 seconds. And so to build a buffer to get people out of the area of the lightning a little bit quicker, I'm going to take 10% of the distance off of the answer. So people are given really a false answer, but it's a much shorter answer that will propel them out of the area. I'm going to do that by using this first constant safety buffer. I want to extract 10% out of the answer. So notice this is a new constant. It is of type double, and the value is going to be 0.10. Now, when I go and I get my input from the user, I'm going to place it, run it through this expression, and it will take 10% out of the results. So I will put the familiar 7.2. Oh my. All right, there's an obvious mathematical problem here that may not be apparent right away. The reason that we're getting such an odd answer is because of something called the order of precedence. This is something you need to be aware of when you are constructing your expressions. Certain operations have a higher order of operation. That is, they are processed before other operations. In the case of our expression, the multiplication operators are going to be processed before the subtraction operator. So no matter what we expected reading left to right, what we're going to get is this times this times this, and then that answer is subtracted from in delay assigned to distance, and that's the oddball that we get out of there. Now, there are a couple of ways you can control the order of operation. You can reconstruct your expression, if that makes sense. But an easier way is simply to use parentheses. So in this case, I want this first in delay times safety buffer. So I want to take 10% out of the 7.2 that we'll put in there. And then I want to modify in delay. I want to take that 10% out of in delay, and then I will multiply that times that. So by putting these parentheses in the expression, it will come to the inner parentheses, and it will say in delay times safety buffer. Then take that result, subtract it from in delay, and then these outer parentheses say take that result times speed of sound. Now I believe if we execute this and give it the familiar 7.2, I think we're going to come up around 7,100. Yes, 7,128 feet away. Now, because it's a much shorter distance, people are going to hightail it out of the area, and we won't have any lightning strike injuries. I hope you found this useful. We have added variables, constants, expressions, and a little bit of I/O to our repertoire in this short lesson. Keep building. Java is an extensive language, but it's easy to understand if you start from the beginning. Good luck on your program.